Okay, we're back, people. All right, let's see how much force it takes for me to pull it up. Our first displacement, we're going to pull this through, is going to be, we're literally going to pull this through 20 centimeters. So our first displacement is 0.20 meters, and we'll see how much force it takes to pull it through 0.20 meters. It looks to me like it was 0.6 newtons. Does that sound about right? Can you guys actually read that?
Yeah.
Okay, do you guys like 0.6? Holler.
Sounds about right.
All right, good. Because it'll be 0.6 every single time, whether I pull it through 20, whether I pull it through 30, or whether I pull it through 40. So I'm going to take this off because we don't need it anymore. And we'll see how accurate it is. So what is the first displacement? I'm going to use 0.20 meters. What's the next displacement I'm going to use? 0.30 meters. What's the last displacement I'm going to use? 0.40 meters. So that means I'm going to drop it. This is actually set at 20. So I'm going to go here. This right here, this is 20 centimeters. This is 30 centimeters. This is 40 centimeters right here. And that should give us all we need to see if we're, correct. So I'm hoping it's going to be. So make sure you put those down in your data table. You know what? I think we can, let's go with 20 centimeters to start. And we may go up by 20 each time, just so we can get a bigger variation in velocity. But we'll see if that makes sense. Okay? Our first velocity reading is going to be this then. Here we go. That's our first reading right there. Our cart went from 0 to 1.15 meters per second. We don't need the time. So it went from 0 to 1.15 meters per second over 20 centimeters. Now, I lied. This next displacement is going to be 40 centimeters. Let's get a good variation and see what happens. I don't think 10 centimeters is enough differentiation between trials. So let's go with more. So this is going to be how fast it goes after 0.4 meters, which is 40 centimeters. Here we go. .57 meters per second. So it went from 0 to 1.57 meters per second, and it did that over 0.40 meters. Let's do it one more time, people. Now, I think it went 1.89. Did that cart bounce back up and change the number? Did anybody notice that? Or did we get a clear reading? What do you think?
I think it was 2.89.
Okay, how about I do it again? I agree. Something funny happened. Let's try it again. Thank you. Well, I don't know. It seems like 1.78 sounds reasonable. So we'll see if that gives us any error or not. So there we go. I think now we've got all of the pieces of information we need to make this work. So let me go back to the actual lab itself. No, that's not it. There it comes. All right, let's get back to our lab stuff right here. I gotta make my screen a little bit bigger. Here, I'm just gonna go ahead and hit me some text boxes up, and then it looks like we went. Work with me here, people. Did we start our first one at 0.20 or did we do 0.10 for the first one?
0.20.
Okay, that's kind of what I was thinking. So our next one was 0.40. And then our next one was 0.60 right there. All right, sounds like a game plan. Now, what's interesting is that we had a locked in value for force. And I know the sensor said negative, but that's just because it doesn't understand directions. So these will all be, go. So. There we go. You know, when you're doing graphs, you do not have to put units everywhere. Like, I don't know why I did that. That's like a random accident. Well, when the graph is, when your data table is titled with the units up there, do not need to put them in here. But you got to have them up in the title, though. That's important. Okay. These are the ones that I cannot remember. So if somebody would be kind enough to walk me through this one. What was our first velocity?
1.15.
I'll buy that. What was our next one?
1.57.
Okay. I mean, they're all going to go up. We know that. This would be, and then what did we say? 1.79 maybe?
Yeah, it was 7.8.
Okay. That's fantastic. Okay. I think everybody right now, oh, the school's power just went out. Holy moly. Whoa. Everything is dark here. Never fear. I'm sure it'll pop right back on. But right now, I may lose the network. So finish. Can anybody hear me?
You still have Wi-Fi?
Are you guys still out there?
I just ended my class.
You guys out? Oh. Yeah, I was just doing a lab.
Oh my God.
That's huge, Courtney.
Oh. Well,
Wow. Whoa, I just finished a lab.
I just finished my class.
Oh my gosh.
Yeah, I sent them early so that they could finish the quiz.
Oh, good for you.
That worked out very well for me.
Dude, that was a big oof.
That wasn't
Oh, this is
Back
bad.
in.
Yeah, usually it goes off and then.
Right, and then.
Yeah. Well, I can update my Schoology on my phone. You can go to Schoology on your phone and update it. You say, kids, power's out, blah, blah, blah. If it becomes a problem. Yeah.
The whole thing. You're like the squirrel? You're like, yeah. I like to cut that whole block near the school. That's true. Not in that.
Oh my God, I should drive to my house right now and do my class from my house. Right. No, all my kids would be freaking out. They're like, how can you know a teacher?
Yeah.
No, I'm not doing that. I have charge, but they won't be that long. I'm not gonna do Google Meet through my phone. I don't even remember what I was actually doing. Oh, we don't have it.
Right.
No, you gotta go data on your phone. Yeah. Yeah, I wasn't even thinking about that. Like, oh, my computer's charged. I can still do that.
You can make a hotspot.
Right.
Well, you can make a hotspot for some. I've done that once with my iPad, and that was terrible.
Yeah, I can imagine. That would work out well and your data would.
Yeah. Yeah, I didn't want to like desperate time stop for desperate measures. It was
Yes.
like everything was super slow, and oh my god, everything was really bad.
It'll probably just snap back on here in a second.
Yeah, normally
I'm not getting very good at anything.